Hi dear students, welcome to VidyaVardhini Academy. In this video, we are discussing numericals on chemical kinetics chapter. Okay, first let us read the question. For a chemical reaction A gives rise to B, it was found that concentration of B increases by 0.2 mole per liter in half an hour. What is the average rate of the reaction? Within half an hour, the concentration is increased by zero point 0.2 mole per liter. As B is concentration of product, it should always increase, right? Half an hour refers to 30 minutes. Now first let us understand what is given. In this given is concentration of B. Concentration of B is 0.2 mole per liter. Okay. And time is given, that is within the time duration, that is delta T equals to 30 minutes. Here it is the concentration which is changed, that is increase in the concentration, hence I will write it as delta of concentration of B. Then how to calculate average rate? Average rate we can calculate by taking minus of R2 minus R1 divided by T2 minus T1. This formula we can use, or there is another formula, or we can also use minus of delta A divided by delta T, as the reactant here in this equation is A. Or another equation which we can use is delta of concentration of B divided by delta T, right? As in the question the concentration of product is given, we can directly take average rate equals to concentration of B divided by the time duration. Here the change in the concentration of B is given 0.2 mole per liter and time is given delta T, that is 30 minutes. Okay. After the calculation, average rate of the reaction is found to be 0.0066 mole per liter per minute. Here as the time value is given in minutes, it becomes per minute. Okay, this is the answer for this question. Now let us read question number 2, that is in the reaction R gives rise to product, concentration of R decreases from 0.03 to 0.02 molar in 25 minutes. Calculate the average rate of the reaction using unit of time both in minutes and seconds. We need to calculate average rate in terms of minutes and also in terms of seconds. Okay, so solution is solution. First let us write what is given in the question. Here the value of initial concentration R1 and the final concentration R2 both are given. Initially it was 0.03 molar, R2 value is 0.02 molar, and the value of time that is delta T is given, which is 25 minutes. From 0 it is taking 25 minutes. Okay, we need to calculate average rate. Average rate equals to minus of R2 minus R1 divided by T2 minus T1. On substituting the values here, R2 is 0.02 minus of 0.02 minus 0.03 divided by T2 minus T1, that is delta T. It is directly 25 minutes. Now on calculation, minus into minus it becomes plus 0.01 divided by 25. We get the value of average rate, that is 0.0004, or we can write this value as 4 into 10 power minus 4, correct? So just I am transferring this decimal to the right side. We get 4 into 10 power minus 4. Unit will be mole per liter per minute. Now the value is in minutes, hence the unit will be also per minute. But in the question as it is mentioned, we need to calculate the value both in seconds and minutes. Right now I am calculating the same average rate in seconds. How to do the calculation? That is average rate in seconds. We got to know what is the change in concentration of R. It is 0.01 divided by 25 minutes. If you convert it into seconds, it is multiplied with the 60. We get the value as 0.01 divided by 1500 seconds, right? Average rate equals to 6.66 into 10 power minus 6 mole per liter per second. Okay, this is how a same question can be asked to calculate in terms of minute and in terms of seconds. In the new competitive exam, either this option may be given or this option may be given. And in board exam, if this question is asked, you need to calculate both in minutes and also in seconds, right? Now let us read question number 3. Calculate the overall order of a reaction which has the rate expression. First, in that first question, A, rate equals to K into concentration of A power 1 by 2, B power 3 by 2. Question B, rate equals to K into concentration of A power 3 by 2 and concentration of B power minus 1. For this, solution is, for any reaction, we will express the rate as rate equals to K into concentration of A power X and B power Y. In order to calculate overall order of the reaction, we will take order equals to sum of power of concentration terms, that is X and Y. If you take sum of these two powers, it gives us order. In the first question, it is a rate equals to K into concentration of A power 1 by 2 and B power 3 by 2. When we take sum, that is order will be equal to sum of these two values, 1 by 2 plus 3 by 2. We will get 2. That is nothing but the reaction is second order. The reaction is second order. Now question B. In question B, the value is given rate equals to K into concentration of A power 3 by 2 and concentration of B power minus 1. If you take order equals to 3 by 2 plus minus 1, which is equal to 1 by 2. Hence, order is half order reaction. Half order. This is also called as a fractional order. Okay. Next, we have question number 4. Now, let us read question number 4. That is, the initial concentration of N2O5 in the following first order reaction, N2O5 gaseous state gives rise to 2NO2 plus half O2 was 1.24 into 10 power minus 2 mole per liter at 318 Kelvin. Full stop. The concentration of N2O5 after 60 minutes was 0.20 into 10 power minus 2 mole per liter. Calculate the rate constant of the reaction at 318 Kelvin. Means the temperature of the value of the reaction is kept constant, right? For this, the solution is, see, we need to calculate a rate constant. I hope all of you remember the rate constant integrated rate expression which we derived in the previous videos. You can check out. That is, rate constant for first order equals to K equals to 2.303 divided by T log of R0 divided by R. This is the equation. As we want to calculate K, let us substitute. K refers to rate constant. Let us substitute time here. Time is given, which is 60 minutes. 60 minutes. Log of R0. What is R0 refers to? It refers to initial concentration, that is 1.24 into 10 power minus 2 mole per liter. Next, concentration of R, which refers to the final concentration after 60 minutes, that is 0.20 into 10 power minus 2 mole per liter. It is given here in the question itself, right? Now, during calculation, that is K equals to 2.303 divided by 60 log 10 power minus 2 cancelled, 1.24 divided by 0.20, we get 6.2. K equals to 2.303 divided by 60. Here log 6.2 should be calculated by using log book, and another method of calculating log, it is by using calculator. In order to understand how to do log calculation by using calculator, please do watch my previous videos. Okay. Now after calculation, we get the value of K to be 0.0304. And here mole per liter cancel. Unit is left only for time. Time is given in minute. Hence the value of unit is here per minute. The rate constant value is K equals to 0.0304 per minute. Okay. Now let us read the next question. A first order reaction is found to have a rate constant K equals to 5.5 into 10 power minus 14 per second. Find the half-life of the reaction, right? We already know that half-life of a first order reaction is given as, in this, half-life is asked for first order. Hence, T half for first order reaction is given by 0.693 divided by K. In this equation, we can clearly understand that Half-life of first order reaction is independent of initial concentration of reactant. It will not depend on the initial concentration. Instead, it only depends on the rate constant value. Okay, and the value is already given in the question. Directly substitute it. 0.693 divided by K value is 5.5 into 10 power minus 14 per second. Once when you do the calculation, the value of T half or half life equals to 1.26 into 10 power 13 seconds. This is the answer. Okay, these are the numericals in chemical kinetics. We need to solve some other numericals that you can watch out in the next videos. Hope you understood these 5 numericals. If you have any doubts, please write down in the comment box. To learn more numericals and to understand chemistry in detail, please do follow our YouTube channel VidyaVardhini Academy. Right? Thank you so much.